Hello, this is Gayatri Murali. I am a developer evangelist with Intel working on Android. Today we are going to be saying about how to build an NDK application using Android Studio. The version of Android Studio, NDK and Gradle are here as shown in the slide. Now let's jump right into the coding. So here is Android Studio. I'm just going to create a new project. Let's call it NDK test. Let's leave it at phone and tablet with Android 19 as the minimum SDK. Blank as activity. My activity is fine. And click finish. I'll give it a couple of moments for it to come up. Okay. It's up and running now. Let's minimize the preview window here. I'll jump right into my activity file. Okay. So now first what we are going to do is we are going to add a native method called here. Native is the keyword that you need to use. Let's say it returns a string and let's call the method hello.jni. Once we add this, we'll quickly do a make project because we want the corresponding debug classes to be generated. Okay, now this is done. Let's also add calls to load the corresponding library once we have the NDK code in place. So let's call that hello.jni as well. Now we've added this. Now let's go ahead and fire up the terminal. We are going to create the JNI folder. Instead of just creating the JNI folder, we'll use the java h command to create the folder as well as the header file that we would require for creating the C code. So let's use java h. We have to be in the source main folder. Okay. Java h -d is to create the new directory called JNI. So I'm going to be calling my folder JNI where I will place all my native code and make files. And I'm going to supply a class path here. The class path is the place where you have your android.jar file present for the corresponding platform. I have it here. You should check wherever your SDK is installed. You should be able to find it there. So it's present within SDK, platforms, Android 19 because we chose that as our minimum SDK platform, and Android.jar, semicolon. Now we have to supply the class files, right? Debug, and then now we are going to give the complete name of our Java file along with the activity name. So it's calm down example.gmo.ndk test.myActivity. Okay. Now if you refresh your main folder, you will be able to see that the JNI folder is created with an appropriate header file. Now let's go ahead and just copy and paste this so that it's easier for us to create hello.jni.c. We will erase the content of the header file, don't worry, I'm just using that too. Now this dots, let's go ahead and first erase what is not required. Right, so let's delete all of this, and this is the function, JNI function, which is going to return something to your Java code, right? None of this is required. Now what is this going to return? Let's return a simple string message. Called hello from JNI. Okay. We need to use the header file that we have created using our java h command. That's it. So you've added your NDK portion here, a C file, which is going to return a string called hello from JNI to your Java function. Now, how do you display this in your Java code? So let's go ahead and create a holder for that. Let's create a text view here. Of this, let's set the text as whatever is returned from our JNI function, and let's set the content view to our text view. That's it. So now this is going to return. Now this is not enough. What we have to do is as we do in Eclipse where we say add native support, we have to add NDK support to this particular project. For that, go to your local.properties file and you will see sdk.dir. So this is where your Android SDK resides, and this is created by default. Copy that and please provide the path to your NDK file. In my case, my NDK and SDK folders are in the same location. So I'm just doing this, but you should be able to provide a path for your NDK folder. Once this is done, we need to tell our build.gradle file, hey, I have a module here for NDK and you should be able to invoke that. So how do we do that? So let's create the call NDK here, and the module name is hello JNI. So we tell the build.gradle file to do this, right? So the next step here is so what I'm going to do here is, this should be fairly enough for you to go ahead and build an NDK project. But what I'm going to do here is I'm going to make use of makefiles. By default, Android Studio will ignore all android.makefile and it will generate one on the fly. But in bigger projects where you have lot of .so files and you need to link them, it's better to have an android.makefile. So I'm going to take it into consideration that there are a lot of developers out there who are going to just port their existing apps onto Android Studio rather than creating a new NDK app, in which case you might want to bring your entire structure here. So I'll just go ahead and add the android.makefile. I have the makefile here already, so I'm just going to add my application.makefile as well as my android.makefile to my JNI folder, right? So I'll just go ahead and add it. So you have your android.makefile. Make sure that the module name that you have here is the same as the module name that you have specified in your build.gradle file. And I'm going to build a shared library which is .so files. If you already have .so files, I'll tell you what you need to do about that in a bit. Application.mk file, this is just to tell that create .so files for all platforms that are available today. Okay, so I have gone ahead and added this. Now, since we have a makefile, we need to tell Android Studio Gradle that, hey, I'm going to do my NDK build on my own and you do not invoke NDK at all. So how do we do that? So we do something called source sets.name and specify this. If you specify this particular line, it means that NDK build.command needs to be invoked from command line, right? You have to do this on your own. Now let's say I want to put all my libs folder in all my .so files that I already have from the project that I'm importing onto Android Studio into the exact same location where I had it in Eclipse. So I'm just going to put it in my libs folder. If you like it, you can keep it libs, or if you want, you can change this to any other name. What Android Studio will do is it will look for your libs file under this folder that you have specified in the build.gradle file, and this means that you have to invoke ndk build.command if you're on Windows, or just ndk build if you're on Mac on your own. So now that we have added this, it's all set. Let's go ahead and fire the terminal, and we are going to call our ndk build command. So I'm just going to go ahead and do it. your ndk build.command will be present in your ndk folder itself, or you can set it as in your path so that you don't have to do whatever I'm just doing. Okay, so we see that the lib files are generated now. So we see that the libs files are generated for every platform, right? Now, how do we, now let's go ahead and take a look at what is happening at the back end, right? Now here is the folder in which I have my example created called NDK test, right? Now within my app folder, build, I don't see anything generated yet because I have not yet executed the program. So let's go ahead and execute this program and see what happens. Okay, now let's launch the emulator. I am going to use the x86 emulator here. Give it a couple of minutes. Sorry about that. So far what we have done is we made a call from our Java file to the function which will which to our JNI function, and then we created a text view, and we populated the text view with whatever is going to be returned from our JNI function, right? And then we created a JNI method .c file where we just added a small function which is going to return a string called hello from JNI, and then we took our build.gradle file and we added a module name ndk, and we added our module name, and we also added this whole module ndk to tell the build system that we have the ndk module integrated in this. And then we went to our local.properties file and we added the ndk path. That's how we add ndk support in Android Studio. And then what we also did is on build.gradle, I'm sorry about this, you don't have to worry. So you see that hello from JNI is printed here. So now this works. Now let's focus a little bit on how the APKs are getting generated, right? Now let's go ahead and take a look at what APK did get generated for this particular app. If you look at your outputs folder, we see that an app debug APK is being created. Now, what if you want to build a separate binary for each architecture that your application is going to support? How do we do that? So for that, what we are going to do now is we are going to add some product flavors into this build.gradle file and then see what happens. So there is this new thing added called build variant. Now you see that it is just two options, which is debug and release for this particular app. Now what I want to do is I want to create build variants for different architectures, and I also want to have one APK which is a fat binary that includes all of the architecture. Now how do I do that? Your Android build system, the Gradle, will not be able to take that information from your application.make file. This make file is just telling my ndk build.command that hey, generate a .so file for all the available architecture. That does not mean that library is being taken into consideration in your final APK. For that, you need to add something called product flavors into your build.gradle file. Now let's go ahead and add that. Okay, product flavors. Now let's add x86 ndk, and we call it, we have to give an ABI filter name on how your APK should be filtered based on what. So ABI filter, and then we also add one for ARM v7a, ABI filter, and we call it ARM ABI 7a. Okay, so that's it. Once you add this, and I'm gonna make project, Don't worry about the error. It's complaining because I have to use ndk build command. That's why it's complaining. I just wanted to show this to you. So once you add product flavors, you see that you can build this application for different platforms and debug and release mode. So let's go ahead and say x86 debug. What it is currently doing is it is building this app for x86 platform, right? So now if I go ahead and run it again, so this APK, an APK file will be generated just for x86 platform when I do that. Okay, so you see that it's still printing my hello from JNI because it's an x86 emulator and I have an x86 debug build. Now what has happened in the backend? Let's go ahead and see this folder. Refreshing this folder, you see that 2 additional APK files are generated, which is debug for x86 because that's what you have chosen as your build variant here. Now what if you have to choose something else? You see, oh I'm sorry, this is a different project. Okay, so you see that we have only these 4. Now what if you want to have a fat binary which includes all of these architectures together? Just add the keyword fat and then let's make the project again and see what happens. You will see that a fat debug and fat release is all added to your build variant. So that's how you will be able to build a fat APK. Now if I choose this and execute this program, right, and run it, I'm just going to choose the same emulator. Okay, it's running. Now you can still see hello from JNI is being displayed. And what has happened here is you see that there are additional 2 APK files that are generated for the fat binary. Okay, so that's how the build variant works. Now I'm going to do something else here, which was recently added in our Gradle 0.13 plugin. Okay, so what was added in Gradle 0.13 plugin is something called APK Split. What it does is it gives you a number of options to do what you want to do with your APK files. A, it helps you in choosing what architecture to include into a particular APK file. B, it tells you if you want it also gives you an option to generate one APK file for each architecture and also a fat binary file which includes all the APK files. I mean all the architecture, right? So you can specify this APK splits in your build.gradle itself using Gradle 0.13 plugin. So how do you update Gradle 0.13 plugin into your project? So I cannot do it in the same project here because it is going to pull the binaries and start installing. So I'm just going to show you how I did it in my another project, right? It's exactly the same project here, and I have, what you need to do is to go to your build.gradle file, not the application one, the entire project build.gradle file, and add something like this 0.13.plus. So once you add this and do a make project, Gradle build system will automatically make sure that you're not behind a firewall, and then you will be able to get all the plugin related binary files onto your project, right? And then we will do this in the build.gradle file. In your build.gradle file, you add something called splits ABI. What do you want to do with the ABI? And then when you do enable true, it means that it is going to create one APK file for each ABI that you have defined per ABI. And universal APK equals true, which means that it will also have an universal APK file which is targeted all the available platforms, right? You can do this once you upgrade your build.gradle file to 0.13.plus. Okay, it also gives you an additional option, like you can specify the version codes here itself. So when you build a fat binary, you need to make sure that you version code it correctly, so that the Play Store will be able to filter out that app depending on the underlying architecture. So you can specify the version code also in this format here. So you see that I have given 1 as the version code for ARM EABI v7a and 2 for x86. So you can add all of this into your build.gradle file itself. I repeat again, you have to add this particular, change it to 0.13.plus in your build.gradle file and do a make project. When you do that, make sure you're not behind a firewall so that Gradle build system is able to update the plugin. Once it is updated, all you need to do is to just add this APK splits, which is splits followed by this. You can do a lot of other things as well with splits, so I would strongly encourage that you go ahead and read the documentation for APK splits. Thank you for listening to me. I hope you find this video helpful. Thanks.